Hi all, and welcome to another Generative Components tutorial. Today I'll be looking at a simple function to automate your paving labels. This method can be adapted to label windows, facade panels, and even pipe lengths. The approach in this tutorial is to utilize some existing geometry and a range box. In Generative Components, you can perform additional tasks based on geometric attributes such as area, color, length, and any other geometric properties available. So let's get started. Here we are in a simple file based on the design seed. In this file, I've just created some simple polygons or rectangles that represent our paving pattern. As you can see, there are three different sizes. If we measure the areas, the smallest is 90,000 square millimeters, the medium is 135,000 square millimeters, and the largest is 180,000. So switching back to computational design workflow, we can click on Point to generate a new base CS by clicking on Yes and then OK to the prompts. And let's place one point at the top left and the other point to the bottom right. With those in place, I just changed the Z values to -50 for the top left and 50 for the bottom right. This will just ensure that the geometry falls within our range box. Dragging in a range node, we can link up the points to the high and low inputs, and the range box is created. As we're going to be placing a text node, one of the requirements is that we need a text style. So next I'm going to drag in the text style node, and the settings I've used for this example is 1 for both the text and height. For the font I have set it to Arial, justification is center, and finally the color is set to blue-violet. The next I'm going to drag in the text node and set its method to byFunction. So clicking on the box icon, we can open the script editor and we can start writing our function. The first line starts with function, and we open the brackets to start our inputs. First will be range. I've called this input range. The next I'm going to use text style, and I've called this style. The next three inputs will be using string inputs, and the labels for those I've called type 1, type 2, and type 3, which will be the text labels that we will be placing on our paving, and close brackets to close the inputs. For the function, we place it inside curly brackets, and now we can start the function. To start the function, I will generate some temporary polygons, which I will call pavers, and they will be generated from elements in range. And for the range, we can use the input range that we just set up in the inputs. We don't need to populate the other options, as we're not interested in filtering or references in this example. For the next step, I like to create a virtual container for the information I'd like to return from the function. In this case, some text, which I will call paving labels. And this I'll just set to an empty container, which is just open and close curly brackets. Now, we need to start a loop to analyze each of the polygons we just created in the first step. So we just type in for, and if you tap on tab twice, it'll automatically populate the lines needed for the loop. For the count, we will add pavers.count, and I just changed the count to an uppercase C. With each loop, I'd like to query what the size of the paver is, and is it within a certain range. One method would be to set the value exactly. However, I found that when you create elements from the range, the value of the area can be varied just a slight amount, like down to the 6th decimal place. This could be rectified with a rounding function, but given the differences between our paving sizes, we could just easily use a range and select the items that we need. So we start a line with if and open brackets to put in the query. And for this, it'll be pavers, and then we're going to use bracket I, being the paver that we're currently looking at, dot area, greater than, so is it greater than 89,000 millimeters? And, so the two ampersand signs, which means, and is it pavers, square brackets I, dot area, again, is it less than 91,000 square millimeters? So this sets up our range. So is it within 89,000 or 91,000? So we put in the process for the if statement with open and close curly brackets. And for this, we're going to create some text, but first we need a point to place the text on. So we start with point, and I'm going to call this center point, and create a new point by centroid of set. And if we use pavers bracket I dot vertices and then close brackets and semicolon, it'll create a new point at the centroid of the vertices from the polygon. Now we can create at the text by placing text, and I'm going to call this my label, and create a new text by point or plane or coordinate system. The point for the placement is going to be the center point we just created. This text string is going to be assigned to type 1, so the first input string we have. And finally, the style is going to be set to style, and we can close brackets and then semicolon. The final line in this if query is to actually place the text we just created into the container that we set up that we want to return at the end. So for this, it's paver labels dot add, and then we open bracket and we place in my label and then close brackets. This will gather together all the text and place it in the paving labels for return later on. So to make it a bit easy to read, I'll just indent this portion of the text. Now for the other tiles, I could simply copy and paste this if statement and change the values. But what I'm going to do is alter the if statement to an else if to make this a little bit more efficient. Now if the first if statement is successful, the second and third won't run. Now if we just change the values for the areas and then change the text values to type 2 and type 3, the last step then is just to place the return value before the last curly bracket. And for this, it'll be return and then paving labels. Click apply and you now can see that text 1 has the new inputs that we set up. So we can close the editor, linking up the range and the text styles. I have input A, B and C into the types, remembering to place them inside quotation marks for string values. And once all the values have been filled in, you can now see the paving labels have automatically appeared. Now this is just a small patch, but if you head over to the transactions, so if we change this to transactions and click on save to record the transactions, if we turn this transaction off, I will copy this pattern a couple of times to the right. If I activate the transactions again, all we need to do is move the bottom right point so our range box covers all of the paving, and you can see automatically the paving is labeled. From this point, I typically drag in an export node and export the text to a separate file so it can be used in our documentation. If the paving ever changes, it's an easy process just to open Generative Components and the labels are automatically updated and exported. So hopefully you'll find a way to incorporate this automation into your next project. Until next time, thanks for watching.